Hello, Numerate, we're back. Okay, so we're in chapter 11, section 11, page 774, number 14. Now we're given that f of x is rad x. We're expanding near a equals 1. We want to use a second degree Taylor polynomial and then estimate the error between 0.9 and 1.1. Okay, so we're going to need three more derivatives. If we're using the Taylor inequality to find the error term, or Taylor's theorem. Okay, I'm sorry, I'm writing the wrong function. It's x to the negative 2. I'm looking at 13. This is 14. And f triple prime will give me the error term, unless you want to use the alternating series test, because I think this is going to be alternating sign. So what is that? Negative 2x to the negative 3, positive 6x to the negative 4, or 6 over x to the 4th, and negative 24 x to the negative 5. All right, so we evaluate this at 1. We want to expand this near 1. It's going to be 1 to the negative 2 is 1. Negative 2 times 1 to the negative 3 is negative 2. F prime at 1 is negative 2. F double prime at 1 is therefore 6. And F triple prime, well, F triple prime we're not going to evaluate, because what we want to do is find the max. We're going to use the max of that derivative on the closed interval from 0.9 to 1.1. That's what, in other words, we're expanding with the center of convergence of 1. So what is my P2? So what's what happened there? Come on, pen. All right, so f of x is approximated by P2, which is f of 1, which is 1, plus f prime at 1, which is negative 2 times x minus a, which is 1, to the 1 over 1 factorial, plus f double prime, which is 6, times x minus a, which is x minus 1, squared over 2 factorial, which is 2. So we simplify that as 1 plus 1, whoopsie. How about 1 minus 2 times x minus 1? And the 6 over 2 is 3, so plus 3 x minus 1 squared. Now the error term, in absolute value, the error, according to Taylor's theorem, or the Taylor inequality, is going to be less than the absolute value of the max of f triple prime of x on the interval from 0.9 to 1.1 times x minus a, which is x minus 1 to the third over 3 factorial, which is 6. All right, so let's find the max of the third derivative, which is negative 24 over x to the 5th, I think. Well, is that a decreasing function? Well, it's approaching 0. It's actually increasing from below y equals 0, isn't it? Let's just confirm that. So let's say f triple prime is negative 24 x to the negative 5, or negative 24 over x to the 5th. There you go. And just display that just to make sure everything's working out okay. I'm just checking my input here. Here it is. And then on the interval from 0.9 to 1.1, where's the max? So let's plot f triple prime. We could do a first derivative test using the fourth derivative here if you want. From x min of 0.9 to an x max of 1.1. Like we said, it's increasing, it's approaching 0, but it's increasing from below. So the maximum value here is Well, the maximum absolute value would be at 0.9, wouldn't it? Yeah. The largest value, the absolute value is the largest value, yeah, in the absolute value. So I'm going to say f of 0.9 is what's going to give me the error term. So if we graph our P2 and our f of x, so f of x, whoopsie, f of x is x to the negative 2, or 1 over x squared, how about that? So let's show that, just for fun. And then our P2, our estimate P2 is going to be, what was it now? Let's see my notes. It was 1 minus 2 times x minus 1 plus 3 times x minus 1 squared. Gotta say times and mean it. Over here too. Alright, so we graph these two on the interval given. We're going to plot a list of f of x compared to P2 of x on the interval in question, which is from 0.9 to 1.1. All right. So let's see. So yeah, it looks like it's pretty divergent. It's pretty bad at 1.1. It's pretty bad. It's a lot worse at 0.9. So what is the error term? Let's find out. So let's show that the error in absolute value is less than, okay, so now what is it? It's f triple prime at 0.9. So I should say it's the absolute value of f triple prime at 0.9 times x minus a, but x is 0.9, a is 1, to the third over 3 factorial, which is 6. All righty. Let's see what that is. All right, so the error is less than that. So what is the actual error? Well, let's show let's compare the error term, P2, at 0.9 to the function of 0.9. And we get, let's see here. Wait, 006, wait, what was my error term? 0.006774, right? So the absolute value there is going to be less than, well, it is less, it's negative, yeah. Well, the absolute value, we're talking about the absolute value. So the actual error is, shouldn't it be less than that? Well, it's less as in sign, but in absolute value, it's not. All right, let's just say that's our answer. The error term is bounded by 0.00677-ish. All right, hope that was helpful. There's your input, there's your output, there's your work, and see you next time. Bye-bye.